Hey, I'm Oliver Jessup, and I'm building a lightsaber. This is the second episode in a series of videos where I talk about the process of building this lightsaber. In the previous video, we went over conceptualizing the design for the lightsaber and actually creating sketches and things for it. If you haven't seen that video, I recommend going and watching it now because it gives a really good overview of what this lightsaber is and how it's all going to work. This video is about the design, manufacturing, and all the testing I did for all the mechanical components of the lightsaber. First part of creating the mechanical parts for the lightsaber was to design them in CAD. So with the help of my initial sketch, I made all the parts in Fusion 360. There's a whole lot of different parts for this lightsaber, but the most important parts are the underframe, emitter shield, grip shield, and the grip butt. The rest of the parts are all just decals. The underframe is what connects the polycarbonate blade to the hilt of the lightsaber, so it needs to be strong to be able to resist shocks from clashes. The bottom of the underframe has a hole that allows wires to be able to pass all the way through it, which allows the LEDs to be able to be connected to the batteries and all the other electronics. The underframe also has a thread on the bottom, which allows it to be able to be screwed into the grip shield. The grip shield houses all of the electronics for the lightsaber except the battery. The battery is actually stored in the bottom of the blade in this section of the underframe. The grip butt is held onto the bottom of the grip shield with 3 machine screws, which allows for easy access to all of the electronics and things in case I need to make any repairs or adjustments. Finally, the emitter shield is slid over the top of the underframe and held on with 6 machine screws. All of these parts have been designed so that they can be milled out on a 5-axis milling machine. It took a while to make sure that all of this was possible to machine, but splitting the lightsaber up into all these different parts helped a lot. Even still, the underframe and the emitter shield are very complicated parts and need a lot of work hold adjustment. And I could have spent more time designing these two parts so that the work holding was less of a problem, but I decided that I'll just bite the bullet in terms of cost and go with 5-axis milling. So when I was happy with the CAD, and before I started spending a whole lot of money to get things made, I 3D printed all the parts so I could figure out tolerances and just do some test fits and everything. And I can actually show you guys the different parts of this lightsaber a lot better with this 3D print. So here the butt of the lightsaber comes off, and you can see that it's actually got a hole in the bottom for a cap to go on. I'll talk about that later, but there's 3 holes for the machine screws. This ring here is actually just like a placeholder for the copper wire that would end up getting wound around this bit. But the copper wire goes on, and then this bit just goes into the bottom of the grip shield, and then you put the 3 machine screws. They go in, and then these indents here, these are for some more decals that just go on the side, and they extend down above the copper wire here. And then this threaded bit here, this can be unscrewed. This is supposed to be a permanent thread, but it just allows for everything to be attached easily. Here's the internal thread, and then the external thread ended up getting a bit destroyed in the 3D print, but it's fine. It still works. But this is why the depth of the thread is so important, is that if it isn't deep enough, this the underframe bottoms out on the grip shield too early, and the holes here for the little brass rods that extend through this middle portion and also end up in the bottom here of the emitter shield. If they don't line up, then I can't get the pipes in, which isn't great. It just means I can't put the whole thing together. But yeah, anyway, these decals here and here are separate parts as well from the emitter, as well as this bit. I actually think I ended up getting this bit anodized, and this decal here goes all the way through the emitter shield and into the underframe to become a part of that as well. But I made these decals all separate pieces just so that I don't waste a whole lot of money machining out all this material here when I don't really need to. It's just a whole lot, it saves money and it saves material, just keeping these bits separate and then gluing them on later. And then yeah, this top portion here is the emitter portion of the lightsaber. This bit is the only part that's made out of stainless steel, but that just allows me to get that really cool coloring on the end of it. But yeah, once I found that everything fit, and once I found that like the right tolerances and everything. I got all these parts sent off to PCB Way for them to make for me. Apart from the copper wire, there's also a few other like aesthetic points of interest for this lightsaber. I added brass rods between the emitter shield and the grip shield, which added some like more variety between the middle section of the lightsaber. I also had the emitter rim, the part that the distance sensing circuit board sits on top of, like made out of stainless steel, so that I could heat it up over like a stovetop, so I could get a like straw blue color to make it look like this lightsaber is actually emitting real heat. I also anodized the underframe black and added a plastic separator ring between these two portions of the grip butt. This meant that this portion here was held to ground by the USB-C connector, and this portion here, as well as the rest of the blade, was left floating. And I did this because I wanted to use the ESP32 touch detection functionality so that I could make this whole upper portion of the blade a capacitive touch sensor, so that if you dropped the blade, it could automatically turn all the LEDs off, which would be pretty cool. And then like as soon as you pick up the blade, it detects that a person is holding the blade, and then it automatically ignites the lightsaber. Which this wouldn't be possible if this section was held to ground. So I just added this like electrical insulator here just so that only this portion was held to ground, and then this whole outer section like acted as a like touch detection sensor. With everything tested, I put together some engineering drawings of like all the critical parts and things, and I sent them all off to PCB Way to get them all made for me. Hashtag not sponsored. But it was really nice having them make it for me, because it meant that like I don't have to make everything myself and like worry about making mistakes and all that, and just it looks way more professional. But it does unfortunately mean that I don't have any B-roll to show you guys. So sorry about that. There were actually a few issues with some of the parts. I have them over here. These three parts I had to get remade a couple of times. These are the bits that didn't work. Um, the first problem was that with this emitter shield portion here, this internal diameter ended up being too small, so it wasn't able to slide over the top of the underframe. You see it just gets stuck. And then this underframe, some of the holes, these holes here in the side were actually drilled off axis, so that I wasn't able, like these holes here on the emitter shield didn't end up lining up with these holes, so I wasn't able to put the machine screws in. But luckily, I was able to get these parts remade by PCB Way for free, which was really nice. But I did get this fixed part here, and while I was tapping the holes, I my tap broke. It's like a tiny little M3 tap, and I was putting way too much pressure on it, and no matter what I tried, I just couldn't get the tap out. And it's actually, you can see it's still stuck in there. So I had to get this part remade, and I did have to pay for that, which was pretty annoying because getting it anodized did bump up the price a little bit, and it's such a complicated part. It has to be milled on a 5-axis machine. But anyway, I just got PCB Way to do the tap the holes for me, which was way better than doing it myself. There was also an issue with the internal threads on the grip shield in that they didn't really go deep enough. I didn't have access to like a metal lathe, so I wasn't like able to like open them up like that. So anyway, I went and bought this monster of an M35 tap. And the way that taps work is that they slowly work the thread open at the bottom, which meant that this tap would bump into the bottom of the like grip shield before it would start opening up the thread, which meant that I had to go and perform a facing operation on the bottom of this tap with one of these grinders. And like this is so incredibly sketchy. Like you should just never do this ever, but hey, it's not dumb if it works. But anyway, now with the thread problem solved, I was able to like polish everything and put it all together for a test fit. And like I gotta say, this thing feels like an actual product. Like I feel like I could just go and sell this thing as is. Like it doesn't even need the electronics or anything. It just feels like it means business. And like the fact that this thing was made out of aluminum as well made it feel like super rigid and like professional, which is just like not what any of my other previous lightsaber prototypes felt like at all. So this was a huge step up. Like, look at this thing. See here, the stainless steel, the straw blue color that I got from burning it. That looks amazing, as well as the anodized aluminum over there, and the copper wire wound around the bottom. That it looks so good. I also got these little side pieces anodized as well, just to add some more contrast, and those look amazing as well. And you can actually see the a little bit of the battery here that I was talking about before. Like the battery is like slightly bigger than the whole length here, but I thought you wouldn't really be able to see it when it was on because there'd be like light out here, and you kind of be distracted by everything else. So I thought that it was alright. Like it would allow me to just keep the whole blade a bit shorter, which was nicer. Yeah, I thought it was a good sacrifice. Also, if you haven't seen the previous two lightsabers I made that I showed in the previous video that I made, you should go watch that if you haven't. I've got them here on my floor. I couldn't really fit them anywhere else, to be honest. But you can see how this is the first one I made. This it's kind of destroyed. Like it really doesn't work anymore. But I 3D printed it. Yeah, there's all the electronics, and it looks like okay, but you know it's not real. It's just plastic, and I put some like metallic paint on it. It doesn't look great. And here's the second one. I put some rub and buff on this one, and it looks a bit better, but you see it's kind of rubbing off, and you can see the plastic underneath. It didn't really last long, and these two blades are also like massive. Like compared to the other this final lightsaber that I made, these are huge. But yeah, you can see like from these two previous prototypes how the machined aluminum just looks so much better. So that brings us to the end of this episode on the design, testing, and manufacturing of all of these parts for the lightsaber. The next episode will be about all the electronic components of the lightsaber and how I made and designed all of the PCBs. If you want to see all the CAD files and engineering design files for the lightsaber, those are all available in my Patreon. So with that, my name is Oliver Jessup. Thanks for watching.